Good morning friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace Transform. In today's lecture, we will discuss inverse Laplace transform by partial fraction method. Now this method is depending on the algebraic calculation. Therefore, today we will find inverse Laplace transform by using algebraic way, means algebraic calculation. Let us see this partial fraction method with some examples. Now example 1, find inverse Laplace transform of s upon s minus 3 times s square plus 4. Now we resolve this fraction s upon s minus 3 times s square plus 4 into partial fraction, means simple fractions. Let s upon s minus 3 times s square plus 4. Now here this s minus 3 be the linear factor. Now we use constant a for this linear factor s minus 3 plus this s square plus 4 be the quadratic factor. Now we use b times s plus c for this quadratic factor s square plus 4, where a, b, c are constant to be determined. Now multiplying this equation by this denominator s minus 3 times s square plus 4. Now by using this multiplication, this denominator get cancelled and answer is s is equal to, now this first term, so this s minus 3 get cancelled, a times s square plus 4 plus in this second term this s square plus 4 get cancelled, answer is b times s plus c times s minus 3. Now by substituting this s minus 3 is equal to 0, that means s is equal to 3 is equal to a times 3 square, means 9 plus 4 plus this s minus 3 is 0, and therefore this second term is 0, and this implies that 9 plus 4 is equal to 13, and this a is equal to this 3 by 13. Now for b and c, we are going to simplifying this term. This implies that this s is equal to a times this bracket, the a times s square plus 4 times a plus b times s into bracket, b times s into s, answer is s square, b times s minus 3 times b s plus c times this bracket, the c times s minus 3 times c. Now this s is equal to, now here s square be the common, a plus b times s square. Now here s is common, plus minus 3 times b plus c times this s. Now this is the constant term, plus 4 times a minus 3 times c. Now we write this s as 0 times s square plus 1 times s plus 0. Now equating the coefficient of s square, s, and this constant term, equating the coefficient of s square, s, and constant term. So therefore here the coefficient of s square is 0, and here coefficient of s square is a plus b. So here a plus b is equal to 0. Similarly coefficient of s is 1. Therefore answer is minus 3 times b plus c is equal to 1. And constant term, so here 4a minus 3c and here constant term is 0. 4a minus 3 times c is equal to, this implies that a plus b equal to 0, that means b is equal to minus a, and a is 3 by 13, therefore b is minus 3 by 13. So this is the b. Now by using this equation, 3 times c is equal to 4 times a, and this implies that this c is equal to 4 by 3 a, and a is 3 by 13. The answer is 4 by 3 times 3 by 13 is equal to 4 by 13. So this is the c. Now substituting the values of a, b and c in here, therefore s upon s minus 3 times s square plus 4 is equal to, this a is 3 by 13, this b is minus 3 by 13, and this c is 4 by 13, and this is equal to 3 by 13 times 1 upon s minus 3. Now we are dividing this numerator by denominator s square plus 4 minus 3 by 13 s upon s square plus 4 plus 4 by 13 1 upon s square plus 4. Now by using inverse Laplace transform to both sides, therefore inverse of s upon s minus 3 times s square plus 4 is equal to 3 by 13, inverse of 1 upon s minus 3 minus 3 by 13, inverse of s upon s square plus 4 plus 4 by 13, inverse of 1 upon s square plus 4. Now this is equal to 3 by 13, and inverse of 1 upon s minus 3, answer is e to the power 3 times t, minus 3 by 13, inverse of s upon s square plus 4, 4 means 2 square, answer is cos 2 times t, because this s upon s square plus 4 be the Laplace transform of cos 2 times t plus 4 by 13. Now inverse of 1 upon s square plus 4, answer is sin 2 times t upon 2. Now this 4 by 2, answer is 2 by 13. So this is the inverse Laplace transform of the given function s upon s minus 3 times s square plus 4. Now example 2, find inverse Laplace transform of s square minus 9 times s plus 15 upon s minus 1 times s minus 2 times s minus 5. Now we resolve this given fraction into simple fractions, means partial fractions. This given fraction is equal to, here this s minus 1 be the linear factor. Now we use constant a for the first linear factor, plus this s minus 2 be the second linear factor. So we use this constant b for the second linear factor, plus this constant c for the third linear factor s minus 5, where a, b, c are the constant to be determined. Now multiplying this by s minus 1 times s minus 2 times s minus 5, we get. Now by using this multiplication, this denominator get cancelled. The answer is s square minus 9 times s plus 15 is equal to, now this first term, so here s minus 1 get cancelled, the a times s minus 2 times s minus 5. Now this b term, this s minus 2 get cancelled, the answer is this plus b times s minus 1 times s minus 5 plus this third term c upon s minus 5, there s minus 5 get cancelled, the c times s minus 1 times s minus 2. Now by substituting this s minus 1 is equal to 0, that is s is equal to 1, then this equation becomes 1 square means 1 minus 9 times 1 means 9 plus 15 is equal to a times 1 minus 2 minus 1, 1 minus 5 minus 4, and this is 0, therefore this whole second term is 0, plus again this is 0, so this third term is 0. This implies that 1 minus 9 minus 8 plus 15 7. Now this minus 1 times minus 4 4 times a, and therefore this a is equal to 7 by 4. Now for b, by substituting s minus 2 is equal to 0, that is s is equal to 2, therefore 2 square minus 9 times 2 plus 15 is equal to this s minus 2 0, therefore this first term is 0, plus b 2 minus 1 1, 2 minus 5 minus 3, and this again this s minus 2 is 0 means third term is 0. This implies that 2 square means 4, 9 times 2 means 18 plus 15 is equal to b times minus 3. This implies that this 4 minus 18 minus 14 plus 15 1. Therefore this b is equal to 1 upon this minus 3 means minus 1 upon 3. This is the b. Now for c, by substituting s minus 5 is equal to 0, that is s is equal to 5. So by substituting s equal to 5 in here, the 5 square minus 9 times 5 plus 15 is equal to this s minus 5 is 0, and therefore this first term is 0, plus again this s minus 5 is 0, and therefore this second term is 0, plus c times 5 minus 1 means 4, 5 minus 2 means 3. Now this 5 square means 25 minus 9 times 5 means 45, plus this 15 is equal to this 4 times 3 means 12. Now 25 minus 45 means minus 20 plus 15, answer is minus 5. Minus 5 c times 12, therefore this c is equal to minus 5 by 12. Now we get a equal to 7 by 4, b equal to minus 1 by 3, c is equal to minus 5 by 12. So therefore this given fraction becomes, this is the 7 by 4, this b is minus 1 by 3, and this c is minus 5 by 12. Applying L inverse to both sides, equal to this 7 by 4 is constant, inverse Laplace transform of 1 upon s minus 1, minus 1 by 3 is again constant, inverse Laplace transform of 1 upon s minus 2, minus 5 by 12, and inverse Laplace transform of 1 upon s minus 5. This is equal to 7 by 4, and inverse Laplace transform of 1 upon s minus 1, answer is e to the power t minus 1 by 3. Inverse Laplace transform of 1 upon s minus 2, answer is e to the power 2 times t, and inverse Laplace transform of this 1 upon s minus 5, answer is e to the power 5 times t. So this is the inverse Laplace transform of the given function by using partial fraction method. Now example 3, determine inverse Laplace transform of 1 upon s minus 2 times s minus 3 whole square. Now We resolve this given fraction into partial fraction, means simple fractions. So let 1 upon s minus 2 times s minus 3 whole square is equal to, so this s minus 2 be the linear factor, so we use constant a for this first linear factor, plus this s minus 3 again be the linear factor, so b upon this s minus 3, but this s minus 3 whole square means this s minus 3 be the repeated linear factor, so we use third constant c for this s minus 3 whole square. Now multiplying this whole equation by this denominator, multiplying by s minus 2 times s minus 3 whole square, so we get by using this multiplication, this whole denominator get cancelled, the answer is 1 is equal to, multiplying s minus 2 s minus 3 whole square to this first term, so we get a times this s minus 2 get cancelled, the s minus 3 whole square, plus in here s minus 3 get cancelled, the answer is b times s minus 2 and s minus 3, plus in here this s minus 3 whole square get cancelled, the c times s minus 2. Now by substituting s minus 2 is equal to 0, that means s is equal to 2, this 1, a times 2 minus 3 minus 1 whole square, plus this s minus 2 is 0, so therefore second term is 0, this s minus 2 is 0, therefore third term is 0, and minus 1 square with the 1, so therefore this implies that a is equal to 1. Now by substituting this s minus 3 is equal to 0, that means s is equal to 3. Now this 1 is equal to a times this s minus 3 is 0, and therefore first term is 0, plus s minus 3 is 0, so therefore second term is also 0, plus c times 3 minus 2 means 1. This implies that this c is equal to 1. Now for b, we are going to equating the coefficient of s square. In here, the coefficient of s square means s into s, here s square, here s square. The a plus b is equal to 0, because here coefficient of s square be the 0. Therefore a plus b is equal to 0, that means b is equal to minus a, and this is equal to a minus 1, b is equal to minus 1. So this such type of calculation we have already seen in the example 1. Now one another method, by choosing s is equal to 0. So by using s equal to 0, in here this 1 is equal to a is 1 times 0 minus 3 square, plus b 0 minus 2 and minus 3, plus c be the 1 times again 0 minus 2. Answer is 1 minus 3 square 9 times 1 9, plus minus 2 times minus 3 6 times b, and this minus 2. Now 9 minus 2 plus 7, and 1 minus 7, answer is minus 6, so therefore 6 times b is equal to minus 6, and then again this b is equal to minus 6 by 6 means b is equal to minus 1, means this 1. Now by substituting this a, b, c in here, now here this a is 1, b is minus 1, and c is 1. Now by using inverse Laplace transform to both sides, the inverse of 1 upon s minus 2 s minus 3 whole square is equal to inverse of 1 upon s minus 2 minus inverse of 1 upon s minus 3 plus inverse of 1 upon s minus 3 whole square. this is equal to inverse of 1 upon s minus 2, answer is e to the power 2 times t, minus inverse Laplace transform of 1 upon s minus 3 means e to the power 3 times t, plus inverse Laplace transform of 1 upon s minus 3 whole square. Now we know that Laplace transform of t, answer is 1 upon s square, and Laplace transform of e to the power 3 times t is equal to 1 upon s minus 3 whole square by using force shifting property. Now by using the inverse Laplace transform of shifting property, its answer is e to the power 3 times t. So this is the inverse Laplace transform of the given function 1 upon s minus 2 times s minus 3 whole square by using partial fraction method. Hope all of you have understood this inverse Laplace transform by using partial fraction method. Please subscribe this channel and let me know your comment and feedback.